Hi everyone. Hello. Hello, my dear students. Am I audible and visible, everyone? Not audible. I think it's muted. Come on, check once. It's muted from there. Just check it once. 1 minute. Okay. Can everybody hear me now? Hi everybody. Hello. Good evening, everybody. Very good evening. Hi Naga Bhargavi. Hello Maitri. Hi Sandeep. Hello Lakshmi. Zeenat. Good evening everyone. YouTube Janta. Good evening Afreen. Varalakshmi. Hi everyone. Good evening guys. Good evening. Good evening everybody. Good evening everyone. Okay. All ready to start the class? I am great everybody. Hi Suprata. Good evening. Hello. Anjali, good evening. Sri Lasya, good evening. Sudeshna, hello. Ramcharan, good evening. Good evening, everybody. All right. So, all set, everyone? Good to go? Ready to see more applications of grandpa equation? Practice more problems in today's class? More problems for grandpa equation, everyone? Okay, very good. Chaliye bhai, so without wasting any more time, let us quickly start with the class. And today's class is going to be full of applications, questions based upon grandpa equation. So let's begin, my dear kids. All right. I hope everyone is having a good time at their homes. So last few weeks you are getting to enjoy at your place with your parents. Please make the most of it. Very soon you will be starting with offline classes where you will be moving to your hostels. So make the most of this time. Enjoy it well, eat well, collect lot of energy, which will be needed for the next 2 years of your preparation. Okay. All right. So let's. You will teach for boys campus. I don't know Sandeep, but whoever will teach will be an exceptional, fantastic teacher. Don't worry about that. The selection procedure of Sri Gosalites Junior College is very rigorous, and each and every member, as I told you in the beginning also, each and every member has been very carefully handpicked by our chairman sir and our academic directors. Okay, so there is absolutely no need for you to worry, whether it's me, whether it's anybody else, all of them will be equally competent. There could be a little bit of difference here and there in the way of delivery in the style, but content wise you will get 100% exact thing. So don't worry about that. Okay, yeah, so don't even worry about that who will be teaching. If you ask me who will be teaching, someone fantastic will be teaching. Okay, so let's quickly start with the question. First question is, let's practice more problems. When will offline classes be started? Karnam, you will be informed about that very soon. Beta, have patience. You will be given proper prior information, and I think it will be starting in sometime in this month only. But exact date I am not sure about, so I can't commit upon that. But it will be starting well in time. Don't worry about that. Okay. So good evening, everyone. Over here also on YouTube. Chaliye, let's practice the questions. Find the mass of residue left. Find the mass of residue left on heating. Find the mass of residue left on heating 2.76 gram of Ag2CO3. Okay. Find the mass of residue left on heating 2.76 gram of Ag2CO3. Atomic masses are given. Silver is 108. Carbon, I hope everybody knows, is 12. And oxygen is 16. Okay. These are the atomic masses. And the equation given to you is Ag2CO3 solid upon heating. Delta means heating, guys. Okay. Ag2CO3 solid upon heating goes to 2Ag solid plus CO2 gas plus half O2 gas. This is the equation given to you. So what is the mass of residue left? Now tell me, what do you understand by this word over here, everyone? Residue. What is the meaning of the word residue over here? Can anyone care to explain? Remains. Yeah, precipitate is not the residue. Residue means something which is remaining. Residual. Leftover. Yes. So now, basically, what I am asking in the question, the insoluble substance and residue are not a very great match. They somehow mean the same thing, but not a very great precise meaning. Ag is the residue over here. See, look at the products, everybody. Look at the products. This is gas. Gas will escape in the surroundings. Okay, gas will escape in the surroundings, and this will be the residue. This Ag solid will be left. The solid material left after chemical process. Yes. So this Ag will be the solid beta. And basically now what you have to do is you have to calculate the mass of Ag that will be left. Chalo, try it on your own, everyone. Try it, everybody. Try this question. Okay. Give it a try. Mass of Ag left you have to calculate. This will be the residue. This Ag over here, this will be the residue. So basically, we have been given 2.76 gram of silver carbonate. Try this for a few minutes, then I will solve this for you. Just give it a try. Take a few minutes, try it, and then we'll discuss it. Harika says 2.16 gram. Okay. 2.16 gram is one answer we have got. Siva case, beta, residue means the remaining thing. Okay, in the products, this is gas, CO2 is gas, O2 is gas. So these two will escape. What will be left in the container? Ag will be left in the container. 2.16 gram. Omkar has given the answer. Jhansi Rani has also given 2.16 gram. Okay. 2.16 gram on YouTube also from Satya Prakash. Well done, guys. Well done. You guys amaze me in every question I am giving you. You have been taught so well by the teachers before me. Well done. Very good. Really happy. This is amazing stuff. Good. Excellent, guys. Chala bahuni. Very good. So what we'll do over here is that we will calculate the moles of Ag2CO3 first. Moles of Ag2CO3. Okay. Moles of Ag2CO3, my dear kids, will be given mass by molar mass. Okay. So given mass is how much? Given mass is 2.76 gram. Upon the molar mass. So molar mass of silver carbonate, if you will add, see 2 Ag. So 2 Ag will become 108, 216. And carbonate CO3 is 60. CO3 is 60. So 216 plus 60 will be 276 gram per mole. Okay. I'm just writing it in short over here. Molecular weight will be 276 gram per mole for Ag2CO3. 2 silver are 108 plus 108, that is 216, and carbonate CO3 is 60. As you practice more and more, so these small group of atoms, you can remember it as a whole. So it saves a lot of time in questions, because a lot of times you will get different types of carbonates. So like I personally store it in my head, carbonate is 60. So whenever I see CO3, I don't think of 12 plus 48. CO3 I straight away think as 60. SO4 I straight away think as 96. SO4 straight away I think as 96. So once you practice more and more problems, these things will start entering your head, and eventually you will find out that this is the difference between an exceptional student and a good student. Exceptional students and good students, knowledge wise they are same, but application wise, practice wise, the way they approach the problem, the speed with which they approach the problem, the kind of exposure they have, that makes separates them. Okay. So Ag2CO3 molar mass will be 2 silvers are there, 216, and carbonate CO3. So 3 oxygen will be 48. 48 plus 12, 60. And 60 plus 216, that will be 276. You can add it. It is basic addition. There is nothing much to explain over here. This is simple basic addition, guys. Okay. So now we will divide this by 260 is 276 gram per mole. 276 gram per mole. So this is 2.76. I will be getting how much, beta? I will be getting 0.01 mole. 0.01 mole. And now this is 0.01 mole. This is the reactant, guys. And we want to calculate the product. Product specifically we want to calculate Ag because this is the residue. We want to calculate the residue. So we can again apply grandpa equation on silver carbonate and Ag. So we will write moles of Ag2CO3 upon 1. Moles of Ag2CO3 consumed upon 1 is equals to moles of Ag consumed upon 2. Moles upon stoichiometric equals to moles upon stoichiometric. Grandpa equation. So grandpa equation on Ag2CO3 and Ag. Coefficient of Ag2CO3 1, coefficient of Ag is 2. So moles of Ag upon 2. In place of Ag2CO3, I will put 0.01. So this you can visualize yourself 0.01 into 2. So moles of Ag will become 0.02 mole. Moles of Ag will become 0.02 mole. This is the moles of residue. Put 0.01 over here. 0.01 into 2. 0.01 into 2 will give you 0.02 moles. And now you can calculate the mass. So mass of residue, that is weight of Ag, my dear kids, will be 0.02 mole. And this will be multiplied by what? Everyone. This will be multiplied by what? The molar mass. Molar mass. Molar mass of silver is given in the question 108 gram per mole. 108 gram per mole. This is the molar mass of silver. Okay. So mole cancel and 108 into 2. 108 into 2 is 216. 216 with 2 decimals. So 2.16 gram is absolutely correct answer. Well done. Everybody who got it in the first attempt. Well done. Yes, Janvi, again we'll do lots of questions. Don't worry. Chaliye, those who are writing it, quickly note it down. This is the question slide. This is the solution. 5 seconds for it. 5 seconds for it. Okay. 5, 4, 3, 2, 1. Beta, moles of silver carbonate is given mass by molar mass. Molar mass is 276. So 2.76 upon 276 will be 0.01 mole. Okay. And if you put 0.01 over here, you will get 0.02 mole. And silver molar mass is 108. Textbook we can buy or given in college. Beta, the study material will be given in the college. Textbook like NCRT and all that you will have to buy on your own. Very good, Ramcharan. Well done, well done. I am proud of you, beta. Chalo, next question. Ready, everybody? Everybody ready, all of you? Over here, Vinishka, Spandana, Anya. Very good, Pramod. Well done. Chaliye bhai. So, one more question very quickly. Next question. Fe plus H2O goes to Fe3O4 plus H2. This reaction is given. It is not balanced. Okay? It is not balanced. Please note that. So before solving it, you will have to balance the equation. It is not balanced. Find the mass of iron. Find the mass of iron. Find the mass of Fe. Converted into. Find the mass of Fe converted into its oxide. Find the mass of iron converted into its oxide. This is iron, this is the oxide of iron. Okay? Find the mass of iron converted into its oxide by action of 18 gram steam. By action of 18 gram steam. And hydrogen and oxygen atomic masses, I am sure everybody must be knowing. Iron atomic mass is 56. iron atomic mass is 56. Yes, Deepika, very good. But this equation is not balanced, people. Before you try to solve it, make sure that you balance the equation. Find the mass of iron converted into its oxide by the action of 18 gram steam on it. That is the name of ore, Lakshmi, not the name of compound. Name of ore. Ore contains impurities also, so it is not pure Fe3O4. Okay. Dr. Naik, when does the offline class start? I think Dr. Naik, I mentioned it at the beginning of the class only, that it will be starting sometime in this month only. Exact date I will not be able to comment, because personally speaking, what is ore? Ignore, they are not needed right now. So what mass of iron can be converted into its oxide? Mansa has got the answer 42 gram. Anya Sharma is also giving 42 gram. V Cookie 232 gram. Chaliye, everybody solve it quickly. Chadri 42 gram. Jhansi Rani 42 gram. Lucky 42 gram. Ram Charan 42 gram. Supraja 42 gram. Nihal 42. अरे क्या बात है बच्चों, very good यार. So first of all, we will 42 here also. Raman Reddy, Hani, Spandana, Anya Sharma. Good. Well done, everybody. So what we will do is we will balance the equation first of all. So guys, see, iron over here is 3. I want 3 over here also. So I will put a 3 over here. Okay. Then oxygen here is 4. Oxygen here is 1, so I will put a 4 over here. And for hydrogen, 4 2s are 8, so I will put a 4 over here. 4 over here, and this is also 4. Is it clear, everybody? Now, information about H2O is given, and information about Fe is asked. Information about H2O given, information about Fe is asked. So what we will do? We will apply grandpa on Fe and H2. Fe and H2O, sorry. Achha, steam by the way is H2O only. I hope this is clear, everyone. Steam is nothing but H2O. Steam is H2O only. It is water in gaseous form. Steam is H2O only. Okay. So we apply grandpa equation on iron and H2O. So we write moles of Fe consumed upon 3 is equals to moles of H2O consumed upon 4. Moles of Fe consumed upon 3 is equals to moles of H2O consumed upon 4. This is grandpa equation. Acha, moles of H2O, I am not calculating it. This is obvious, 1 mole. Water molar mass. Steam is what? Steam is H2O only, na? So water molar mass is how much? 18. So 18 gram means 1 mole of water. Okay. So in place of water molar mass is 18. So 18 gram means 1 mole of water. So in place of mole of water, straight away I am going to put the value. Okay. This much. Right? Eventually, as we are proceeding up and practicing more and more problems, our level should increase. Na? We should become smarter and smarter. Every time we should not write down the basic steps. So some of the steps we should be able to do mentally also. Okay. So moles of Fe upon 3 is equals to moles of H2O. I will put as 1 beta. Moles of H2O I am putting as 1. Okay. And from here I will get that moles of Fe consumed will be equals to 3 by 4 mole. Moles of Fe consumed will be 3 by 4 mole. And now my job is to calculate the mass of 3 by 4 moles of water. Sorry, 3 by 4, I said water. My job is to calculate the mass of 3 by 4 moles of iron. So I am going on the next slide. So therefore, mass of Fe will be 3 by 4 moles. 3 by 4 moles, this is Fe. And molar mass of Fe, how much, everyone? Molar mass of Fe is 56 gram per mole. 56 gram per mole. So mole cancel, and I am sure you can realize this. This becomes 14 fours are 56. So 4 will cancel 56 14 times. 14 threes are 42 gram will be your answer. Well done, everybody. Everybody got this answer by all of you? 42 gram. 42 gram, everybody. Very good, very good, very good. Ramcharan, yesterday you were not happy. Are you happy today? Superstar of South, Ramcharan. Where is he? Well done, Pramod. Very good, Ramcharan. Good. Okay. All right. So 42 gram is the mass of heavy. Next question, guys. Everyone ready? All of you? Before slide, yes. Have a look, beta. Next question, everyone ready? Sir, the questions are difficult. Of course, who said life will be easy? I never said I'm going to teach you 2 plus 2 equal to 4. Of course, the difficulty level will increase gradually. That is the idea. But I will increase it in such a way that you will not realize it that it is becoming difficult. Okay, next question. Chalo guys. So next question is that find the mass of O2. Next slide. Which slide, bhai? Which slide are you talking about? This slide. Quickly write it fast. Take a screenshot. I will share the QR code. You will get the whole notes after the class also. Don't worry about that. Chalo. So now 1 minute. Let me don't keep it in the sequence only. So next question is that find the mass of O2 needed for find the mass of O2 needed for complete find the mass of O2 needed for complete combustion of 2.8 kg 2.8 kg ethylene. Find the mass of O2 needed for complete combustion of 2.8 kg ethylene. 2.8 kg ethylene. So what is ethylene first of all? Here I am not giving you the equation. I want to check whether you know this logic or not. First of all, what is ethylene? Ethylene. Ethylene, C2H2 is acetylene. Ethylene is the common name for ethylene is the common name for ethene. Ethylene is the common name for ethene. And ethene is an alkene, beta. Ethene is an alkene. Molecular formula is C2H4. Okay, ethene is an alkene. Molecular formula is C2H4. Okay, everyone. C2H4. So this is an alkene. Molecular formula C2H4. And this is a hydrocarbon. Everybody understands what are hydrocarbons? Hydrocarbons are compounds of carbon and hydrogen. Okay. And any hydrocarbon on combustion with O2, produces any hydrocarbon in this world, any hydrocarbon produces CO2 and H2O. CO2 and H2O. Yes. So I am not writing the equation this time. You have to write the equation, balance it, and then calculate the answer. You have to write the equation. Heat and light also, okay, that's a separate thing. We are interested in the reactant and product. Manasa is giving the answer 3.2 kg. Abhi is giving the answer 9.6 kg. Let's see. Try, both of you check your answers once again. First, let's write the balanced equation. So C2H4 plus O2 goes to CO2 H2O. Any hydrocarbon on combustion will give you CO2 plus H2O. Now is the time to balance this equation. So 2 carbons, 2 I will put over here. 4 hydrogens, 2 I will put over here. So 2 carbon balanced, 4 hydrogens, 2 2s are 4 balanced. And oxygen becomes 2 2s are 4 and 2, 6 oxygens. So what should we put? What shall we put over here? What will be the coefficient of O2? 2 2s are 4 and 2, 6. So what will be the coefficient of O2 over here? Everyone? 3, 3, 3. Very good, very good, very good. Coefficient of O2 will be 3, guys. Well done, everyone. Okay, coefficient of O2 will be 3. Yes, yes. So now we will calculate first of all the moles of ethene. Moles of ethene. Moles of ethene is 2.8 kg. So 2.8 kg means 2.8 into 1000. Because kilo stands for 10 to the power 3 beta. Gram, this is the given mass, okay, upon molar mass. Molar mass is 2 carbon, 24 and plus 4, 28 gram per mole. Molar mass of ethene, 2 carbons, 24 plus 4 hydrogens, 28 gram per mole. Gram cancel and this will become how much? This will be 2800 upon 28 mole, which, my dear friends, I am sure everybody can understand, will be 100 moles. So 100 moles of ethene is there. 100 moles of ethene is there. Ethene was how much, everybody? 2.8 kg, guys. 2.8 kg is 2800 grams. 2800 grams divided by molar mass is 28 grams per mole. So this is 100 moles. For 100 moles of ethene, how much O2 needed? Now you can do it orally also, yeah. 1:3. 1:3 ratio. 1 mole needs 3 moles. So 100 moles need how much? 300 moles. That's it. Or you can apply grandpa also here. 100 upon 1 is equals to moles of O2 upon 3. If you want to apply grandpa, so you will write 100 upon 1, same thing, is equals to moles of O2 upon 3. So moles of O2 will be equal to 300 mole. 300 mole. 9.6 kg or 9600 gram is absolutely correct answer. Very good, Mahit. Very good, Satya Prakash. Very good everyone. Pramod. 9.6 gram, 9600 gram. Okay, 100 mole O2 is there, na? So mass of O2 will be equal to 100 mole multiplied by molar mass of O2. Molar mass of O2 is 32 gram per mole, right? Molar mass of O2 16 plus 16, 3200 gram. Acha, sorry, this was 300. Sorry. O2 was 300, na? I'm very sorry. O2 is 300 mole. Yes. So 300 into 32 gram per mole, mole cancel, and this will be equals to 9600 gram. 9600 gram, which can be written as 9.6 kilogram divided by 1000. 9.6 kg is also correct. 9600 gram is also correct. 9.6 kg is also correct. 9600 gram is also correct. Okay, quickly have a look. Moles of O2 is 300 mole. Well done, guys. Well done. Very good. Great vectors you all have become. Good. Sir, your voice is not audible. Navya. Sandeep T. Once explain how you formed that equation, but which equation are you talking about? This chemical equation. Monica and Nivin. Sandeep T, you are talking about this chemical equation. But I have not formed it. You have to remember that any hydrocarbon, thank you Siva Keswa beta. Time is going very fast in chemistry class. Tank machine. Beta, any one of our friends T Siva has requested for more practice. So I just write down a few questions. Beta, see, any compound which has carbon and hydrogen is called a hydrocarbon. And hydrocarbons on burning with O2 produce CO2 and H2O. Always. Any hydrocarbon on burning with O2 will produce CO2 and H2O. This is also called as combustion. This is also called as combustion. Okay. So, for example, if you have methane, this is called methane. Methane plus O2, my dear T Siva, will give you what? CO2 plus H2O. C2H6 is called ethane. Ethane plus O2 will give you what? CO2 plus H2O. Balance all the equations. Incomplete combustion is in limited supply of oxygen. That leads to formation of CO. Will you repeat this in offline class? Yes. C2, H4 we have done. So balance these two equations, everybody. Balance these two equations. Balance these two equations quickly. T Siva, specifically for you, you were asking, na? This is hydrocarbon, beta. Hydrocarbon on combustion gives CO2 plus H2O. Any hydrocarbon in this world. So one carbon, 4 hydrogen, you can put a 2 over here. 4 hydrogen, you can put a 2 over here. 2 to the 4. And oxygen becomes 2 and 2. 2 and 2. Total 4 oxygen. So you will put 2 over here, 2 to the 4. This is balanced equation. So look over here. 2 carbon, 1 carbon. Put a 2 over here. Okay. 6 hydrogens, 2 hydrogens. So put a 3 over here. Now oxygen becomes how much? 2 2s are 4, 2 2s are 4 and 3 7. Pragna, have patience, beta. With practice you will learn it. Don't worry. 2 2s are 4, 3 7. 7 oxygens. So I want 7 oxygens over here. What should I do? 2 are already here. I want 7 oxygens. What should be the coefficient, everybody? What should be the coefficient, everybody? 7 by 2. Yes, very good, very good. Because 7 by 2 into 2. 7 by 2 into 2 will be 7. So this is also perfect way of balancing, guys. Perfect way of balancing. This is also how you can balance the equation. Okay. So this is the balanced equation. It can. I said yesterday also, Lakshmi, Ram. Yesterday also I said it can be fraction form. I said this. This is a very common misconception people have, that it should be a whole number. It is not necessary. Eventually it is a ratio. It can be anything. Chalo. So next question now. These two are understood. Chalo. Next question very quickly, everybody. Next problem. Next problem is that find the volume of O2 gas produced. Find the volume of O2 gas. Fraction and decimal are same thing, Ashika. 7 by 2 can also be written as 3.5. Fraction and decimal are same thing, na? So find the volume of O2 gas produced at NTP by 367.5 gram of KClO3 solid. 367.5 gram of KClO3 solid. KClO3 solid. Sorry. And KClO3 solid. And atomic masses are given. K is equals to 39. Chlorine is 35.5. Oxygen is 16. Okay. And if you have attended yesterday's class, so you must be already knowing this equation. You must be knowing the balanced equation. Yesterday's class also this example came. Similar type of question. I mean, reaction was same, question was different. but you can use that same equation. In case you have forgotten it, I will write the equation 2KClO3 solid on heating goes to 2KCl solid plus 3O2 gas. Chalo bhai, everyone do it quickly. Zenith Ara in question equation is always given, not necessary. Initially, still you are a small kid, it might be given, but then as your knowledge of chemistry increases, you are supposed to know some of the equations also. So some equations are very basic equations like combustion of hydrocarbon and all that you should know, but initially it will be given. But as you will mature, as you get to know more and more about chemistry, you will, you are expected to know some equations also. Every equation might not be given. Mansa has got 100.8 liter. Do it, everyone. I don't know whether it is correct or not. Let everyone else get their answers. Come on, everyone, quickly. Lots of people are giving 100.8. 100.8 on Zoom. What about YouTube? 100.8 here also. Okay, so first of all, 100.8 looks correct to me. Let's check out. So first of all, we will be calculating moles of KClO3. Moles of KClO3 will be equals to given mass by molar mass. Given mass is 367.5 gram upon molar mass. Molar mass of KClO3. Who calculated this? This will be 122.5 beta. 122.5. Maitri, check it again. 39 plus 35.5 and 3 oxygens. 48. It will come out to be 122.5 gram per mole beta. Very good, yeah, very good. So, like 122.5, 367.5 gram per 2. How much is this? 3 mole. 3 mole. And now you will apply grandpa on KClO3 on O2. So you write mole of KClO3 upon 2. Mole of KClO3 upon 2 is equals to moles of O2 upon 3. Is equals to moles of O2 upon 3. Moles of O2 upon 3. In place of moles of KClO3, I can put what? 3 by 2 is equals to moles of O2 produced. Moles of O2 produced upon 3. So moles of O2 produced how much, bachcho? Ram and Sham problem again. Moles of O2 produced is equals to 9 upon 2 mole. 9 upon 2 mole. This is moles of O2 produced. And now I am supposed to calculate the volume of this O2 at NTP. So 9 by 2 mole, when I want to calculate the volume, so volume at NTP will be 9 by 2 mole. This is the number of moles. Multiplied by what? 22.4 liter for 1 mole. Again, mole cancel. 2 will cancel this. 9 into 11.2. 9 into 11.2 liter, capital L. 9 twos are 18, carry over 1. 9 ones are 9 and 1, 10. Carry over 1 and 10. 100.8 liter will be the final answer. Well done, very good. It is solid. O2 कहाँ solid है यार? O2 is gas only ना? KClO3 is solid ना भाई? O2 is gas. Is this clear, everybody? 100.8 liter is absolutely correct answer. Some difference between NTP and STP. Let's save some things for the day when you are here. Practically almost same. Match 3. Ready for next question? 100.8 liter. Everybody is clear? But I got 95.8. So that is wrong. Please replay me. How can I replay you? I can replay a video. How can I replay a person? Is that possible? Sindhura, next question, sir, please. Yes, Sindhura, next question coming, don't worry. Charan Kumar Reddy, next question, sir. Clear, sir? Okay, very good. Chalo, next I will teach you another concept now related to stoichiometry. Sometimes you get questions on percentage loss in mass. So I will give you a small glimpse of it today, and then in the next class, that is tomorrow, we will discuss it further. Percentage loss in mass. So percentage loss in mass is no theory as such, straight away a type of question. So we will attack it with the question only. Okay. Question is find the percentage loss in mass. Find the percentage loss in mass on heating. Find the percentage loss in mass on heating Carbo-3. Carbo-3 means CaCO3. Just finally I call it Carbo-3. Okay. CaCO3 calcium carbonate. Okay. Find the percentage loss in mass on heating CaCO3. This is the question. Only this much is given. And atomic masses are also given. Calcium is 40. Carbon is 12 and oxygen is 60. Now listen to me, madam. Okay. So on heating Carbo-3, what happens? Carbo-3 CaCO3 solid goes to CaO cow plus O2. CaCO3 goes to CaO solid. CaCO3 solid goes to CaO plus CO2. Carbo-3 goes to cow plus O2. Okay? Short form way of telling the equation. So now see what will happen over here. CaCO3 is calcium carbonate. CaO is calcium oxide. It is also known as slate lime. Nahi, bhai, slate lime is calcium hydroxide. CaCO3 is limestone. Okay? CaO is quicklime. Chaliye, that is general knowledge. Let us come to stoichiometry now. So CaCO3 is CaO plus CO2. Now tell me, when you are heating it, law of conservation of mass says that mass of reactants before the reaction is equals to mass of products after the reaction. Have you heard about this? Mass of reactants before the reaction is equals to mass of products after the reaction. If you have not heard it, then hear it now. This is called law of conservation of mass. Mass can neither be created nor be destroyed. Okay? So then why will there be loss in mass? See, whenever they ask you to calculate loss in mass, it is understood by default that reaction will take place in an open container. If the reaction takes place in a closed container, then loss in mass is zero. No loss in mass. Because mass will remain conserved. But if the reaction takes place, so that is no question. If it is saying calculate loss in mass, it is understood that you have to think about an open container. So in open container, what will happen is that if any gaseous product is there, it will escape. And once the gaseous product escapes, due to that, there will be loss in mass. Did you understand the reason for loss in mass? The reason for loss in mass is if any gaseous product is there, the gaseous product will escape from the container. And due to that loss of gaseous product, there will be a loss in mass. So here what we will do is that we will say, like, we have not been given any amount. So let us say we have 1 mole of calcium carbonate. Now 1 mole of calcium carbonate, what is the ratio? 1:1:1. So 1 mole of calcium carbonate on heating will produce 1 mole of CaO and 1 mole of CO2. Okay? Ratio is 1:1:1. So 1 mole CaCO3 will be consumed and 1 mole of CaO will be formed and 1 mole of CO2 will be formed. Now this 1 mole of CO2 being a gas, will escape from the system. Maitri, we have just taken 1. If you are not happy, you can take 1 crore. But 1 is a cute number, na? So I like cute people. I am a very cute person and I like cute numbers and I appreciate cuteness in everything in my life. Okay? So we have to calculate percentage. So we can take just 1 over here, no problem. If you are not happy, you can take 2, you can take 10,000, you can take 1 crore, you can take X. Finally, you will get the same answer. Understood now, by everybody? Why I have taken 1? Cuteness, small numbers are cute numbers. We should appreciate that. Okay? So 1 mole CaCO3 will give you 1 mole CaO, 1 mole of CO2. This CO2 will escape. So now tell me, what will be the loss in mass? 1 mole CO2 goes out. Pawan Kumar says you are also cute. Thank you so much. 1 mole CO2 ka mass how much? By how much? Enta. 1 mole CO2 mass enta. 44 gram. 44 gram loss in mass. Okay? 44 gram loss in mass. Now, you must have calculated this percentage increase, percentage decrease upon original into 100, increase upon original into 100. So this is the loss in mass. Okay? And now let us come to the initial mass. Initial mass is what? This is the initial mass. Initially means before the reaction, yaar. Okay? So before the reaction you had 1 mole carbo 3 CaCO3. अरे CO2 का मोलर मास यार 44. 1 mole CO2 बेटा 16 plus 16 32. 32 plus 12 44 in Vijayawada. 16 plus 16 is 32 in Vijayawada. 32 plus 12 is 44 in Vijayawada. I hope wherever you stay there also 32 plus 12 is 44 only. All over India it is 44. Okay? And initial mass is 1 mole of calcium carbonate. 1 mole of calcium carbonate, what is the molar mass beta? Calcium 40. Carbonate I told you 60. Carbonate straight away I remember. CO3, whenever I see CO3, in my mind 60 starts coming. I don't look for carbonate. CO3 means 60. Okay? CO3 60. Lucky Nixie says sir 0 is much cuter beta, but इतना भी cute नहीं होना है कि आंसर ही नहीं आए ना. आंसर तो लाना है. Namaste sir, we are seniors. Yes. Hi, hello everybody. But what are you doing in this video yaar? You are learning stoichiometry. So initial mass is 1 mole CaCO3, which is 100 gram, and therefore percentage loss is loss upon original into 100. Loss upon original into 100. 100 cancel, 44% is the answer. Okay? Lot of you. Initial mass means mass of reactant. Pramod bhai, Pramod Anna, initial mass means mass of reactant. I have assumed 1 gram, 1 mole of reactant. I have assumed 1 mole of reactant. If you are not happy with 1 mole, you can assume 2 moles. Loss of mass in this case is same. My 3 in every case it will not be same. In this case it is coming out to be same. How do we know how much mass is lost? That is the mass of the gas. Mass of gas is the mass lost. Arey, I considered 1 mole, yaar. I assumed let there be 1 mole. If you are not happy, you can say let there be 1 crore mole. Still also you will get the same answer. Because 1 crore mole will give you 1 crore mole. And then your loss in mass will be 44 crore gram. Yes, Omkar Karu. If there is no gas in equation, then no loss in mass method. Your question itself has the answer. But we should take cute numbers, You don't need to learn any atomic masses. Garu means out of respect, Omkar ji. You are a respected person. That's why. Okay. ठीक है? All right. So I am giving you one more question. Time is up for today's class. We will discuss it. How did you get 100 gram? Because 40, my initial mass is mass of 1 mole calcium carbonate. Initial mass is mass of 1 mole calcium carbonate. Okay? And 40 plus 12 plus 16 3s are 48 is 100 in Vijayawada. Homework I am giving. Find percent loss in mass. Find percent loss in mass on heating. Find percent loss in mass on heating. MgCO3. My 3 here you are asking now doubt that 44% loss and percentage same. This time it will not come same for MgCO3 and KClO3. So MgCO3 equation you know, KClO3 equation you know the atomic masses. These 2 questions you will try at home. Okay, this is that kind of homework like at WWE it says na. WWE matches you have seen. Please don't try this at your home. But this is something which you have to try at your home. 2 is enough. Need to be maintained in such type of questions. What I did not. Equation you have to write, Siva bhai. Equation you will write on your own. You know the equations for this. Otherwise, I will tell tomorrow. Please try this at your home. You watch WWE matches or not? This is +1 syllabus, of course. So WWE, what do they say at the end? Please don't try this at home. But this is something which you have to try it at your home. Okay? These stunts have not been performed by trained experts. You can try this at home. Equation for MgCO3 I will tell tomorrow. MgCO3 will be similar to CaCO3. You have to think on your own. Otherwise, I will tell tomorrow. Okay? Arey, what happened to the code? Code is not coming for some reason. I don't know why. MgO plus CO2 is correct, beta. It's not coming. So anyways, you have made the notes. Okay? Chalo, bye guys. Bye. Bye Spandana, bye. Basha, Varshita, Nadeem, Srilasya. Bye everybody. Bye everyone. Take care, guys. Bye everyone. Bye to all YouTube people. Bye to all Zoom people. Love you all. Miss you all. Come soon. We all are waiting eagerly for you. Okay. Bye everybody.
Hey,